Hello and welcome back to K-Tech Designs. My name is Seth. In this video, I'll show you how I modeled and configured this air return grill in FreeCAD. Now this project comes from my very old house, which has these imperial dimensioned air return grills that I can't find anywhere on the internet. And the grills that I have are getting rusted and the paint chipping. So I decided that I would design and 3D print replacements. So in this tutorial I'll show you how I modeled them, how I configured them with the spreadsheet, and the finished result. Stay till the end of the video to see the finished product. And with that, let's get started. So from the start menu, as always, we'll create a new part. I'll note that I'm running version 0.2 build 2. So create a new part. Let's go to the part design workbench. Let's create a part container. And inside that part container, let's create a body. Sorry, I got ahead of myself again. Let's go to the spreadsheet. Create new spreadsheet. That way it can be the first feature in our part. Now we can go back to part design, create a body, and then I'll create another body. We'll name this first body right half, and then the second one left half. Let's start with the spreadsheet and get that configured. Config name overall length in millimeters. Overall height, also millimeters. Hole spacing, half grill length, grill height, grill gap, grill blade count, and wall thickness. Alright, we'll start with a 11 by 7. Let's set up our aliases. So this one I'm going to call overall length, OAL. This one is overall height, I'm going to call OAH. This one will be hole spacing. This will be half grill length, grill height, grill gap, blade count, and wall thickness. Let's set up some variables first. Now I actually modeled this part in inches, and so we're going to actually have to do all of our formulas and math over here, and those will feed into these configurations here. So we'll take these headings, copy, paste, change these to inches. Looks like I need to put in grill length. Don't need wall thickness. Don't need blade count. Okay, I'll just change those. Alright, so now we can put in our values in our formulas. So we'll start a row down because this row will end up being the configured row. So we'll start here. 11.25 for that one. 15.25 for the second one. 7.25, 7.25 because they are the same height. 10.625 and 10.625. So that's the overall spacing between the first and last grill. Grill length will equal cell M4 minus 1.75. And so that's setting a, oops. Copy paste that. That's setting a buffer distance to the edge of the frame. And so then half grill length is just going to be N 4/2. Grill height is 5.125. And an 1/8 inch for the spacing. And a 1/4 inch for the gap. So now these are all the parameters that are going to drive our millimeter dimensions and then some of our calculations like the blade count. The wall thickness I believe I keyed in as just 2 millimeters, so I'll just put that in there. So now let's do our conversion. So this will equal, of course, K 4 times 25.4. Same with the overall height, so that's going to equal L 4 times 25.4. Putting equals in there. Hole spacing as well, so that's M4 times 25.4. This one I could just do D4/2. It'll give me the same result. Oh, sorry. That's because I didn't need the overall grill length. I just needed the half grill length to be the configured dimension, but I still wanted to know the overall grill length. So let's check grill height. That's P. Alright, so this is where we do a little bit of funky math. So this is going to equal round because I want a whole number. P4 over Q4 plus R4. P4 is the grill height, Q4 is the grill spacing, and R is the gap. Gotta have it capitalized. Take all of that, copy it down. And that's correct. The blade count will only increase based on the overall height. So let's say I change the overall height to 8. That wasn't significant enough to change it. Let's try 9. 12. I have discovered an issue. This grill height to get to 5.125 should equal L4 minus 2.125. Copy, paste that. So now if I go to 8, then my grill count goes up. There we go. Move that back to 7 1/4. Okay, perfect. Now I'm going to take, I think I just need to key these in just so it has something. Now let's see if we can make our configuration table. There it goes. So our spreadsheet's done. Now we can start building our part and referencing those variable dimensions. Alright, so let's start out modeling the part. Let's pick the ZX plane, XZ plane. Okay, we'll just pull it out of there after we create it. Okay, we want this sketch at this level, outside of the part. Let's edit that sketch again. So now let's draw our overall size rectangle. And this will be a global sketch that we'll use to reference and drive dimensions on the parts. Let's make these symmetric. Now the overall height will be formula driven, so we'll do Spreadsheet dot OAH, and for this one we'll do Spreadsheet dot OAL. Click OK on that. I also want to add in a reference to the whole layout. So let's put a couple circles in there. Constrain them to 4 millimeters in diameter. I'm actually going to split this left side and then make them equal. And then I'll add a horizontal constraint so that it's in the middle of the part. Okay. We'll make these two circles symmetric. Alright, and then we'll set their spacing to a formula. Spreadsheet whole spacing. Alright, we can close that sketch. So now let's go to the draft workbench. We'll select our sketch, create a clone, and drag it into the right half body, and repeat the process for the left half. Whoops. Can hide that. Alright. So now let's begin modeling the right half. Let's create a sketch. Yep, on the front plane. And because we're modeling in halves, I'm going to make the upper right quadrant the location for the part. And here you can see that we can reference, well, let's make sure we are only referencing this one. I'm going to grab that point there, and then we'll make these 2 points coincident. Close that. Now we're going to do a shell feature. So we'll just extrude, let's reverse that. the thickness is, this is one dimension that we could have added to the spreadsheet list, but I'll just key it in for 22.225. Hide that for a second. Alright, so we can add in a chamfer before we do the shell. Let's make that 3 millimeters. I always do that. Add those two edges there. So now we want to click this face and this face, hold Control, click. We'll do a shell, and then we want to make that our wall thickness. So we'll do spreadsheet.wall thickness. We actually want this to go inwards. There we go. Click OK. And we could even add in a 2 millimeter fillet on this face. Alright, that looks good. So let's get that hole copied. Create a new sketch on the XZ plane. We'll grab this circle here, and let's put another circle on top of that. We'll dimension it to 6. Close that, and then we'll use the hole feature. And we're going to use the UTS course, number 8 screw. I usually like to use a loose clearance on those. The depth we'll just say is through all. Okay, it looks good. So now we can create our fin cutout. So we're going to cut out the fin shape, and then we're going to come back in and extrude the actual fin. So it'll look like it's a formed sheet metal part. So let's create a next sketch on the XZ plane. I'm going to start out with a rectangle, and then we're going to let's dimension this width right away. So that's spreadsheet, so spreadsheet dot half grill length. That is the correct dimension. Then we can do it this way. This height is going to be spreadsheet dot grill gap 6.35, which is our 1/4 inch. I'm going to dimension to the vertical axis 6.35 millimeters. Now I actually want to grab this point here. So let's grab that point. And then I'm going to create, let's see, I think I can grab this point as well. And I'm going to draw a line here. And, not that one, and we'll split it, making these equal. And then we'll make these 2 points horizontal. And then I'll make these 2 points vertical. And I'll make these 2 points horizontal. And I'll dimension the overall length of those 2 points to be grill height. So I wanted to set the overall height of the part. So as this changes in dimension, then it's going to be a symmetric feature where so the thickness between this edge and the wall on either end will always be the same, rather than if this dimension changes, then I might have a larger gap up on the top than on the bottom. Let's add in a sketch fillet to round this sketch off. And I'm going to make these, grab that, make them equal with a radius of 3. Okay, close that. And we'll grab that sketch, turn it into a pocket. Now why didn't it like that? Oh, right, because these should be for reference, so turn those off. Those should be whatever your reference color is. Try that again. That looks correct. And I'll do through all. Click OK. It's looking pretty good. So now we want to model the fin, or the blade, whatever we want to call it. We won't need this right now. So what I'm going to do is I'm going to grab a sketch off of the side plane here, and we're going to create a... let's close that first. I'm going to move the sketch attachment, and I'm going to make it 6.75, knowing that we dimensioned this thickness as 6.35. I'll add a little bit of a buffer in there, so that when we model the part, there's a little bit of a gap, but you'll see. So let's go back into the sketch. I'm going to bring this back. I'm going to hide that. So we are going to want the grill height again to make sure that our parts line up. So I'm going to bring back in this sketch, and we'll grab this point here. Hide that now that I have my point. And we can dimension our construction geometry off of that. So let's dimension, let's dimension the overall length of those to be Spreadsheet dot grill height. All right. So now we know that this is the center, so we can bring this, or not the center, the bottom there. All right. And then based on our sketch position, there's a little bit of a gap there. So let's begin with a line, horizontal line, and then let's angle it up this way. Come back orthogonal, come down like that, and then I think we'll put in a little bit of a radius. Let's just put in a 3-point arc, like that. Make those two tangent, and those two tangent. Make these perpendicular, and those perpendicular. Perfect. Now we probably want to set a an angle here, so we'll pick that bottom leg to the horizontal axis and dimension it at 45 degrees. Okay. Perfect. Let's give this bend here a radius of 1 millimeter. It's likely that I over dimension this, so let's bring it down. Let's dimension this leg to be thickness. Come on. And we also need these to be equal. Make those equal. Alright, perfect. So now we need to dimension that point to the bottom at 5 millimeters. Perfect. Now we can bring that back. Now we can extrude this, and we're going to use a formula, Spreadsheet dot half grill length, and we're going to subtract 1 millimeter because we set this gap at 0.5 millimeter, and we want it to be equal on the other side, so half 1 millimeter. Now at this point, I've been putting in a fillet on these corners, but they have been very unstable when it comes to doing the linear pattern, so I'm going to leave them off at this point just so that the model will resolve, just so that the model won't break down. But you could tell that if this was an actual sheet metal part, and that's kind of what I'm looking for as far as the modeling aesthetic goes. These should be rounded, but we can add those in at the end even if we wanted to. Okay, so that's looking really good. I'm going to save doing the actual pattern until one of the later features. That it seems to help stabilize the model, because the face naming, the edge naming changes a lot when you're adding and subtracting quantities of pattern features, so it's best to be the last feature in the list. But now we need to think about how we're going to connect these two halves together. Now, the simplest way is to just fasten it together. So I'm going to create a little block on either end here, and we're going to bolt it to the other side. Now we need the feature to be the same size for both the left half and the right half. So I'm going to create another global sketch like this, and we'll use that to drive that feature. So let's create a sketch on the YZ plane. I'm going to hide that pad. I'm going to bring that in. So we're going to want, oh, I don't actually need that. Let's do some construction lines here. Let's split that as well. Okay. So this is a mirror plane. I'm going to make these equal. Come on. And I'm going to make their overall height, of course. Oh my gosh. Spreadsheet.oah. Okay. Perfect. Now let's add in a rectangle, and I'm going to set its spacing from the edge. I just key in 2 millimeters, but we're going to make this spreadsheet dot wall thickness, and the same in this direction. I guess we can go to that point. Spreadsheet wall thickness. Alright, now this part's a bit arbitrary. We can just do 13 millimeters by 10 millimeters. And I'm going to add in a reference hole. Let's dimension horizontally 4.5 millimeters. And I suppose we could make this center as well. So technically it would be 5, but maybe I always want it center. No, we'll just do 5. And we'll make the diameter 3.6. Okay, so that is meant to be reference. Alright, so now let's take all of these sketch entities and we will mirror them. Pick the last entity as the mirror plane and we'll mirror them over here. And then I'll add in my symmetric constraints. Oops. Alright, let's make these two equal. Let's make these two equal, and that will set those. Let's make these symmetric. And that should be enough for those. I'll delete that so that I can add in an equals constraint. So I only edit the diameter one place. Alright, that's enough for that. Close it. Let's drag it out to the part here. We don't need to see that. Let's go to the right, go to the draft workbench and clone that and drag it back into the right half. Let's bring back in the visibility of our part. Make sure that it's in the right place. Perfect. I'm actually going to use this not as a reference for other features, but just for this feature. And we'll go back to the part design and I'll just pad it. And we'll make that 7 millimeters. Alright, so let's do our whole sketch. We can use this visible sketch as a reference. Actually, let's go back into editing that sketch and I'm going to create a split line equal. Does that mess up down here? It does. So I'll grab this leg and this leg and make those equal. Alright. Now I just really like using these clone features because I just changed that sketch. This updated by itself and it didn't blow up the pad. Okay. That is just a very, very good feature of CAD models, is the rebuilding and updating of references. Alright, so let's make a sketch on this plane, YZ plane, and I'll just draw some circles for visual reference, and what we want is for these to start on this surface, so I'm just going to move the sketch over 7 millimeters like that. Let's go back into this sketch. I'm going to hide that body, but I can show, well, we can use this one. So I'm going to grab that point there. No? Should allow me to grab that point. Can I grab anything from here? Alright, we'll have to use the clone sketch. I'm not sure why that was not allowing me to do that. This diameter doesn't matter because we're going to control it with the whole feature, but I'll set it to something similar. Set those horizontal. I'm going to have to let's close this sketch. I forgot what dimensions I set here. We'll just copy those. 5 and 4.5. Yes, I don't need to see that. .5, and I don't need to set the 5 because I'm going to set that in that way. You know, I suppose I should set it up that way. Make those equal. Yeah, let's go back into this sketch, and I'm going to go ahead and split this line as well. If I can click the right tool. Equal. Maybe I'll even turn this line into a... Oh, you don't like that? Fine. I won't do that then. So let's edit this sketch again. I'll grab in that reference. We'll make these horizontal, and then I'll make these two vertical. And that'll set those. So now let's use the whole feature, and we'll make this metric. A regular profile. It's for an M3. Use a wide clearance. We'll go through all. And actually I want to change the type to a counter bore. And the default dimensions are appropriate. The next thing I want to do is I want to add a rib here to stiffen up this web. And a simple way to do that is to do a sketch on the top plane, and then we'll do a symmetric extrusion. And I didn't model it on the top plane, so actually what we can do is we can select the top plane, but we can change its Z dimension, its Z position, and we'll do it formulaically. And we'll just set it to Spreadsheet overall height over 2. Alright, now we can go into the sketch, and I'll make a little leg here, and we know that this is going to be the wall thickness, so let's pick the right references then. We'll make it spreadsheet dot wall thickness, and actually this leg is wall thickness as well, so spreadsheet dot wall thickness. So all that's left to dimension is the height of this rib, and I'm just going to make it 3 millimeters. Now we can do a symmetric, not reversed, symmetric pad. And this can be a formula as well. We can use spreadsheet dot overall height minus 2 times Spreadsheet dot wall thickness plus 10. 10, of course, because that's how long this leg is. Click OK, and that calculated perfectly. Excellent. Now I'm going to add in a couple of fillets here. We'll make it 2 millimeters, and these two edges. Okay, that's looking pretty good. Now all we need to do is we could try and put a fillet on these edges here and see how it rebuilds. Alright, now we're ready to do the pattern. So we need to grab, let's see if I can find it. So we need the pocket, the pad, and this final fillet. So let's grab that pocket, pad, fillet, and we'll do a linear pattern. Let's pick the let's pick this axis, which is axis C. Okay. Now for the length, this is our formula spreadsheet. Should be grill height. Yes. It's not just grill height. It's actually, the calculation is a little funky. So it's grill height minus spreadsheet dot grill gap. That way that this thickness is the same as this thickness. And then the occurrences, of course, is spreadsheet dot count. Hopefully it's in here, blade count. Let that update. Click OK. Alright, that didn't turn out bad at all. That looks great. Okay, that's half. That's 1/2 of the return grill. But let's just check. Let's make sure that things are working. I'm going to go to the 15x7. Perfect. No issues. Alright, let's go back to the 11x7. I love it. Now we have to repeat that entire process in order to complete the left half. So I'm not going to put you through that. You should be able to follow all the right half stuff to do the left half. So I'll just do a fast forward of me modeling the left half just to give you an idea of how to do it. Alright, now this is where I can come back in here and things are going to get a little bit different. So in order for these two parts to mate together, I actually want a threaded feature on this end. So you could, tap a hole, run a tap through this hole, an M3, and that probably would work a couple times, but it's not going to be very strong. You could put a heat insert in here as well, but those usually require a lot of space, and they are very, very good if you can do them correctly, but yeah, it requires a soldering iron or something hot to set them in. So I find that the easiest way is to just use a rectangular cutout and insert a square M3 nut. So that's what we're going to do here. So let's start a sketch on the front plane. And I'm just going to back it out -15 millimeters, and that's going to be your 13 millimeters here plus the thickness. And we probably should actually do that. Let's do Spreadsheet, wall thickness. Let's put this in, well, we could just do -13. There. That's set. So let's edit this sketch. Rotate it here to the rear. And I'm going to draw in a couple of rectangles. And we can find where the our boss extrude sketch is, and we can bring in, I did that wrong, undo. I want to bring in that point on both ends. There we go. I guess since I have my reference points now, I can hide the body there. And what happened to my other rectangle? Oh, I didn't make it yet. Alright, let's continue. I'm going to split this leg, make the split parts equal, and we'll go horizontal to our reference there. Now the actual cutout should be 1.9 by 5.75, and these are dimensions that I have found in my experience to work best with the accuracy of my machine, so you might have to change those a little bit depending on the fitment. Generally speaking, I like to clamp the part in this direction, and so if you have any issues with the part not fitting, I would open up this dimension and try to keep this one as tight as possible. Alright, so then let's set our distance here. We'll just make it 3 millimeters. That'll be plenty of thickness to clamp against. And then I'll just repeat that rectangle down here. Okay, close that. Let's bring back the visibility. And now we need to cut it to a depth which will make sure that the fully inserted nut will be concentric with this through hole here. And so my estimation for that, reverse that, is 7.25. Now the way I've been making sure that this depth is correct is I'm measuring the center, from the center of this hole to this face, it should be 2.75. That seems to give the best results for concentricity. Alright, now we can add in our 2 millimeter fillets. Oh my gosh. Fillets on those corners there. And now we're going to want to add in our stiffener rib. So again, we'll reference the top plane. And I want to make the position Spreadsheet dot overall height all over 2. Now we can edit that sketch. Okay, so that's still hidden. And I'm going to go ahead and hide that because I know that the rib should be on this side. So again, let's make this rib wrong dimension. Spreadsheet dot wall thickness. And this dimension as well. My gosh. And the leg length is 3 millimeters. Okay. Let's not reversed symmetric, and we're going to do that formula. Spreadsheet overall height minus twice the spreadsheet wall thickness plus 10. Perfect. Now let's do our linear pattern. Yes, let's do our linear pattern. I'm going to add in these fillets quick. 2 millimeter fillet on those corners. And so we'll grab the pocket, the pad right after that, and the fillet. Make sure to grab the base Z. Yep, that looks correct. And we'll set the dimension to Spreadsheet dot overall, Grille height minus Spreadsheet dot Grille gap, and the spacing is Spreadsheet dot blade count. And that's it. That's a completed design of an air return grill for your house. Now you can take these dimensions, and you wouldn't even have to do much more than creating a configuration to add in even standard sizes for this part. So let's go ahead and check the configuration for the 15 by 7. Check that the left side is working. Thinking. Okay, there we go. Looks like the holes are in place. The grill length is in place. And we didn't break the model when we changed the configuration. Alright guys, that's it for this video. Please let me know what you thought down in the comments. Please like the video if you liked it. Stay tuned for the completed model at the end of the video. And until next time, Thanks for watching. Bye.